Hello viewers, you are welcome. In today's tutorial, we are going to be looking at how we can get the cube root of this very large number. Okay, so without using calculator. So what are we going to do? So quickly, I'm going to be writing this in expanded form as. So I have this in expanded form as this. You can see we have 999. So now 999. Okay, then 1 2 3 4 5 6 7 8 9. So therefore we are going to be having 9 zeros here. When you want to write this 7, 1 2 3 4 5 6 7 8. So the zeros will be 8. The same thing 2 if you want to write it like that. So when we add all of this together, so we are going to have what we have here. So now the next thing we are going to do, so let's try to write each of these in index number. So we're going to have this, I mean this one here. Okay, this is equals to this, that is this inside, this one here inside. So we have 999 multiplied by 10. Well, you count the number of zeros, so we don't have 9 to the power 9 plus 7 times. If you count the number of zeros, we're going to have 8, about 10 to the power 8, right? Then plus 2 times here. If you count the number of zeros, we're going to have 10 to the power of 4, then plus here we can have it to be 9999. So now from there, the next thing I'm going to do is here, since this is 999, so I can write this as 1000 minus 1. 1000 minus 1 will actually give me 999. Then multiply by 10 to the power of 9, then plus 7 times 10 to the power of 8, plus 2 times 10 to the power of 4, then plus I have here to be, since this is 999, that is 9999, I can rewrite it as 10,000 minus 1. Are you following? So now from there, we move on by writing this 1000 here in index number. We're going to have 10 to the power of 3 minus 1, then multiply by 10 to the power of 9, plus 7 times 10 to the power of 8, plus 2 times 10 to the power of 4, plus here is going to be 10 to the power of 1 2 3 4 minus 1. Are you following? So the next thing, we move on. So now let's try to open the bracket. So we're going to see that 10 to the power of 3 times 10 to the power of 9, we're going to have 10 to the power of 12, then minus 10 to the power of 9 multiplied by 1. So this one is going to be 10 to the power of 9 minus, then plus 7 times 10 to the power of 8, plus 2 times 10 to the power of 4, then plus 10 to the power of 4 minus 1. So now we continue. So we're going to have here, I want to try to bring out a common factor. So when you look at this, we can see that we have 10 to the power 12 here, and the least exponent that we have here is 10 to the power of 4. So I'm going to rewrite this 10 to the power of 9 in this form. 10 to the power of 12 minus, I can write this as 10 to the power 10 times 10 to the power of 8. This is like 1 here, which is, I just splitted 10 to the power of 9 to 10 to the power of 1 times 10 to the power of 8, then plus. So now let me write this. I'm going to have 10 to the power of 4, okay, then to the power of 3 minus here I'm going to have let me take this 7 first, okay, because I'm having something common here, which is 10 to the power of 8. So let me take 7 times 10 to the power of 8 to the front times 10 to the power of 8, and I will take this to the back. I have 10 times 10 to the power of 8. Here I have 10 to the power of 4 to the power of 3, plus here you see that if I try to factorize this, so I'm going to be left with 7 minus 10 multiplied by 10 to the power of 8, because I factorized 10 to the power of 8 out. So this is going to be 7 minus 10. We have 10. So now here, what we are going to do now is 10 to the power of 4 to the power of 3, and this is going to be 7 minus 10, that's going to be 3, minus 3 times 10 to the power of 2, right? Sorry, to the power of 4 to the power of 2, plus, so I'm going to have here, now look at this place here, plus 2 times 1 times 10 to the power of 4 minus 1. Is it going to be times? It's plus 1, sorry, plus, because I tried to factorize 10 to the power of 4 out, 10 to the power of 4. So therefore this is going to be 2 plus 1, 2 plus 1, sorry about that. Then we have 10 to the power of 4 to the power of 3 minus 3 times 10 to the power of 4 raised to the power 2, then plus 3 times 10 to the power of 4 minus 1. So now according to this place now, let A equals 10 to the power of 4. If A equals to 10 to the power of 4, so we're going to have everything here to be A to the power of 3 minus 3A to the power of 2 plus 3A minus 1. So now when you look at this, look at the coefficient here. The coefficient here is what? Is 1. Is hidden, right? We have the coefficient here is 3. We have 3 here and we have 1 here. So which is the same thing as having, if you factorize this one, it can be written as A minus 1 to the power of 3. A minus 1 to the power of 3. So now try to open this, okay? So you are going to have this. And at the same time, when you look at the Pascal triangle, okay, so you can see that this is 0, this will be power 1, 1 plus 1 we have 2, this will be power 2, then 1 plus 2 we have 3, 2 plus 1 3, we have 1 1. So this is the power 3. So now when you look at the coefficient of each term, this is 1 here, so this is 3 here, and this is what? This is 3 here, and we have what? We have 1 here. Then if you try to open this bracket, this is what you are going to have here, right? So because of time, so therefore you can see that everything we have A minus 1 to the power of 3. So now, and what we have here is that, so recall that this inside the radicals is what gives us what? Is what gives us A minus 1 to the power of 3. And look at this, we have the cube root, so which shows that this, we cancel the cube root, we are going to have A minus 1. Do you understand now? That is, this is going to give us A minus 1. But recall that A is what? A is 10 to the power of 4 according to what we have here. So therefore, since A, because 10 to the power of 4, so we're going to have, this implies that 10 to the power of 4 minus 1. And 10 to the power of 4 is what? 10,000 minus 1. And we're going to have our final answer to be 9999. So therefore, it's going to be, the cube root of this is going to give us what? 9,999. You can see that we could able to solve this problem without using what? Without using a calculator. And that is the end of the class. If you find this class very interesting, kindly share. If you have not subscribed, consider subscribing today. Don't forget to hit on the bell icon so that you'll be notified anytime you upload a new content. Thank you for watching. Bye bye.